Hello students, myself Antara Bhushan, Assistant Professor of ECE Department in Guru Nanak Institute of Technology, and I am going to give you a lecture under the module 1 which is charge carriers in semiconductors, and the topic is continuity equation. This is my lecture 7, and now what is continuity equation? Continuity equation basically which describes a concept where that means a change in carrier density over time due to the difference between the incoming and outgoing flux of carrier plus the generation of the carriers and minus the recombination of the carriers. Now the flow of the carriers and recombination and generation rates, with all these are illustrated in this figure, where that is the incoming incoming flux, that is the outgoing flux. Here x is first the distance is considered as at x, and that is x plus dx, means that part is dx, that is the distance, and electron currents and possible recombination and generation process is shown in the figure. Now already you know what is Rn. Here is the Rn is the electron recombination rate, and Gn is the generation rate for electron, and Jn, here we are considering n electron, and Ec is the conduction band H, and Ep is the valence band. And now here electrons can jump from the valence band to the conduction band, or conduction band here conduction from the conduction band jump to the valence band. Now the rate of change of the carriers between x and x plus dx equals the difference between the incoming flux and the outgoing flux plus the generation of the carriers and minus the recombination of the carriers. That's why here written that del nxt with respect to time by dt a dx equal to j n x by minus q, that is the incoming flux, and minus the outgoing flux, that is the Jn x plus dx by minus q, into A for area plus generation rate Gn xt minus of recombination rate Rn xt into area A dx. Here n xt is the carrier density, A is the area, Gn xt is the generation rate, and Rnxt is the recombination rate. Now if we use the Taylor series expansion, then we can write that Jnx plus dx, here Jnx plus dx equal to Jnx plus d of Jnx dx. And this equation can be formulated as a function of the behavior of, as a function of the derivative of the current. Now if we represent it like that, then it will be written as del nxt by del t equal to 1 by q del jnxt by del x plus gnxt minus rnxt. here we are using the function of the derivative of the current, okay, that is equal to this. Now similarly for hole we can write this del pxt by del t equal to minus 1 by q del jpxt by del x plus gpxt, that is the generation rate for hole, and minus rpxt, that is the recombination rate for hole. Now if we take a solution of this equation, that can be obtained by substituting the expression for the electron and hole current, which is dn equal to mu n kt by q equal to mu n vt, and dp equal to mu p kt by q equal to mu p vt. Now what is dn and what is dp? dn is the electron diffusion coefficient and dp is the hole diffusion coefficient, and the unit is centimeter square per second, that is that's also centimeter square per second. Now what is diffusion coefficient, where it comes? Because due to the diffusion current it comes. Diffusion current means when the current flows due to the concentration change in the concentration gradient. That's why when current flows, then that current is called diffusion current. And if we calculate the diffusion current, diffusion constant, then this dn and dp comes. dn is the diffusion electron diffusion coefficient, and dp is the hole diffusion coefficient. Okay. Now next is dn equal to mu n plus mu n into kt by q, and dp equal to mu p kt by q. Now all of you know that what is K Boltzmann constant. T is the temperature, Q is the charge, and mu n and mu p. That this mu n is the mobility for electron and mu p is the mobility for hole. Mobility is the measure of ease of carrier drift. Okay. Now that is equal to mu n vt, and that is equal to mu p vt. And now next we put this into that equation, and it will be like that. Here the electric field which is obtained from Gauss's law, that is del nxt by del t equal to mu n del ext by dx plus mu n del nxt by del x plus dn del square nxt by del x square plus generation rate gnxt minus recombination rate rnxt, and this will be equal to, and this equal to minus mu p, that's for the electron, and that is for the hole. dp dxt by del t equal to minus mu p del e epsilon xt plus mu p del p xt by del x plus dp del square p xt by del x square plus gp xt equal to this. A generation in the generation in 3 dimension is the following continuity equation for electrons and holes, that is del in x y z t. Because of 3 dimensional, then x y z t by dt equal to this, and del p x y z t by del t equal to minus of this. Okay. Now, first, for continuity equation, first, what is continuity equation we have to know. Then, the equation, that is the ingoing flux, outgoing flux minus the generation rate and wave, plus the generation rate and minus of the recombination with respect to area. That's why comes this equation. Then J, we'll write J in x plus this equal to this. Then the equation can be formulated as a function of derivative of the current, like that. And similarly for holes also we can write from this equation, we can write the whole for the equation for the holes, that is that is equal to del pxt by del t equal to minus 1 by q del jpxt by del x, that is equal to also generation rate for holes minus recombination rate for generation rate minus recombination rate for hole. And now we know these two equations, that is for drift coefficient and for electron, and diffusion coefficient for electron, and diffusion coefficient for hole, that is dn and dp equal to dp by q, where mu(n) is the mobility for electron, also mu the mobility for hole. And using these two equations we can write that for electron it will be written as del n xt by del t equal to this, and for hole we can write this equation. Now if the generation is in 3 dimension, then we can write that this is the function of 3 parts, that is x, y, z. That's why it is written as del n x, y, z, comma t with time equal to this, and del p x, y, z, t by a equal to this. This is the continuity equation.